we talked about the t distribution and finding the critical values on the chart. So today we're going to put that together with the test statistic for t. We used this formula in the past when we were calculating a t value, and then we used it for like our critical values and our confidence intervals, things like that. So it's the same formula as what we use for z, where you do the x bar minus the mu. The only difference is the standard deviation on the bottom. Instead of a standard deviation of the population, now it's a standard deviation of the sample. What we're going to do today is use that in conjunction with critical values and rejection regions that we've talked about before to do the hypothesis testing. So a lot of this is really similar to what we did in the last section with the z's. The biggest difference is you have t's on your critical values, and you're calculating a t standardized test statistic to decide if you're going to reject or not reject. The rest of this is pretty much the same. So as soon as we know we don't have that population standard deviation, we know it's a t. We also want to double check at the beginning if it's normally distributed or sample size is bigger than 30. We're going to state the null and the alternative. Level of significance is going to be given to us. Extra step on this one is you need the degrees of freedom, which is n-1, to get your critical value, which then you can find on your chart. Rejection region will determine if it's a left tail, right tail, or two tail test and draw those shaded areas. We'll calculate t. We'll figure out if it's in the rejection region or not. If it's in the rejection region, we reject. If it's not in the rejection region, we don't reject. And then we're going to summarize same as before. All right, so we're going to do this one together. Used car dealer says that the mean price of used cars sold in the last 12 months is at least $21,000. You suspect this claim is incorrect and find that a random sample of 14 used cars sold in the last 12 months has a mean price of $19,189 with a standard deviation of $2,950. Is there enough evidence to reject the dealer's claim at a level of significance of 0.05? Assume the population is normally distributed. Okay, so running through the checks at the beginning. Is my sample size bigger than 30, or is my population normally distributed? We're normally distributed. Good. Okay, next thing we're going to check, because eventually these are going to start to be mixed up, is you want to look at your standard deviation, and you want to decide, is it a population standard deviation, or is it a sample standard deviation? In this problem, it came from the sample of 14 cars. So as soon as we know we have a sample standard deviation, we know we are using t's in this problem and not z's. All right, let's write the null and the alternative hypothesis. So the claim that's being made is the used car dealer says that the mean price of cars sold in the last 12 months is at least $21,000. Is that a null or alternative hypothesis? If it's at least, yep, it's going to be the null. And what's the inequality symbol that I'm going to use? Less than, greater than, equal to. What would at least become? This one.
I can never remember though.
How did we get to this point in high school and we still don't know the names of these?
Left open, right open. That's what I think around that was always too easy. So
they were just like, oh, let's just open it this way or this way. We won't actually teach you the names of anything back in 3rd grade.
No, because they taught me how to credit us.
Okay. And that's my claim. My gator analogy.
See, that's what I learned too. I'm like, gator doesn't say.
That's why I use it, because everybody knows the gator analogy. Okay, so what's the alternative then? That the mean is less than. Yep. Okay, so can you tell now if it's going to be left tail, right tail, or two tail? It's going to be left tail. All right, and we had a level of significance of 0.05. So you can go ahead and find it on your chart now as soon as you know that. Oh, no, I need one more thing. I'm sorry. What's my n? So what's the degrees of freedom? 13. Always one less than your n value. Okay, so on our charts, left tail, so you're going to find one tail. We're going to go over to the level of significance, 0.05, that's the second column, and then go down to degrees of freedom, 1.771 is my value for t off of the chart. And then remember, you're always going to get positive values on here, but you need to adjust. Sometimes we have to add a negative. Sometimes we have to add a plus or minus in front of it. Do I need to add anything to this one? If it's on left tail, you're going to have to put a negative in front of it. It's on the left side of my curve. Right tail, you don't have to add anything. And then two tail, you just put the plus or minus. So then you can sketch that. Here's my rejection region. Okay. All right, so now we need to figure out what our t value is from our data. So this is this formula, x bar minus mu over s over square root of n. Okay, so what's the sample mean in this problem? Sample mean. That's the 19 number. Minus mu is going to be always in your hypotheses there. So we have that 21,000. Sample standard deviation, 2950. And then square root of n, sample size we said was 14. You're just going to type that in the calculator. In the red calculator, guys, you need to put the whole numerator in parentheses and the whole denominator in parentheses, or do it in two separate pieces. In the graphing calculator, you can use your alpha y equals, which makes it a little easier. And you should get negative 2.297 for that t value. Okay. All right. Did you type it in all at once with alpha y equals? Oh, okay. All right, so now we compare that to the rejection region. Is that number in the rejection region? Yes. Okay, so what does that mean we do? Reject or not reject? We reject, and remember, you're always rejecting or not rejecting the null hypothesis, okay? So we're saying that that null hypothesis mean greater than or equal to 21,000, we're rejecting that. We're saying that's not true. So to summarize then, we can say there is enough evidence to reject the car dealer's claim. To prove him wrong. Okay. All right, so we use the word is because we rejected, and we use the word reject because our claim was the null in that final sentence there. All right, so pretty similar to our Z hypothesis testing here, just a couple little things we have to change up because we've got a t distribution that we're using. Questions here? Okay, so the only other problem we're going to do then, I'll let you guys decide. Do you want to do a problem about pH in rivers, or do you want to do the DMV problem? pH. All right, there you go. All right, you guys are going to put answers on the board for this one in a couple minutes. Try it. All the steps. Awesome. And then we put up, I'll do cell phone lotto, yep. And then homework, these are the dates that I'll erase that in a second, adjusted for you guys, and I'll do cell phone lotto.